morning, good afternoon, good evening to Le Monde, everyone in the world. We're excited to have you here on this month's October's webinar, Energy Gigs webinar. My name is Jason Asir. We have an esteemed guest, Allegra Hosford Scheirer. She's a research scientist at Stanford University, also the principal consultant of Geomodeling Solutions, and also your expert on everything related to geologic hydrogen. Allegra, thank you so much for joining us today. We're excited to have you on. We know we have lots of people joining, ready to learn more about this topic, and I have lots of questions for you. But
Thank
before
you. I'm so glad. It's great to be here. So I'm hearing a lot of feedback from you, Jason. I'm hearing
Okay.
everything you're saying twice.
Okay. We'll just see if we can fix it as we go along.
Yeah.
Well, so I'm really excited to have you on, Allegra. Thank you so much for sharing your time. You are actually at a geologic hydrogen conference in Alaska as we're talking. So,
Yeah.
Real quick, for those people that are new to Energy Gigs, new to these webinar series, just to do a quick plug about what Energy Gigs is, and then we'll jump right into the topic at hand. So Energy Gigs is a work and talent platform that connects energy companies to talent over hourly, fixed fee, temp to perm projects. For experts on our platform, it's really a lead source. It's the source of new projects for you. For companies, it's a quick way to find experts on various topics, including geologic hydrogen and other areas of the energy industry. So super excited. Allegra, thank you again for joining. If you don't mind, share a little bit about your background and how you got into geologic hydrogen, because I know you have a kind of a unique story of how you got into it.
Yes, thank you so much for inviting me. I'm excited to learn about Energy Gigs. So this hopefully is the beginning of a fruitful partnership. What's kind of cool about natural hydrogen for me is that it makes me feel about 20 plus years younger, because these are the types of rocks, the rocks that generate hydrogen, that I did my PhD on. And the types of sensing tools, potential field data, gravity, and magnetics, that I use to study these types of rocks, ultramafic rocks. And so I'm just thrilled to bring back my career now after 22 years of working in oil and gas, petroleum systems as an academic, to this nascent field of natural hydrogen.
Well, how, like, when you were in your oil, so we'll kind of maybe start with the industry topic as a whole. For people that don't know, what is geologic hydrogen? What is natural hydrogen? I think, yeah.
Natural hydrogen is potentially a whole new energy source. It is hydrogen that's produced within the earth and accumulates, although we don't know much about hydrogen accumulations. And then the idea is that we can produce these hydrogen accumulations to use hydrogen as a fuel, as an electricity source, as a new, perhaps a new source for making ammonia. So any of the things that we use hydrogen for now, it would be a much cleaner way to obtain hydrogen than the way we currently manufacture hydrogen.
That's awesome. I mean, we all, I think, have heard about the hydrogen rainbow of various various colors of creating hydrogen, and this would be the purest form because it's not created from methane. It's not created from.
That's right. That's right. Yeah, so the way we produce hydrogen now produces over 1,000 megatons of carbon dioxide per kilogram. And the only carbon dioxide you would generate by producing natural hydrogen would be associated with the actual, perhaps, drilling, et cetera. So it's a very clean energy source.
And is like, when was sort of natural hydrogen first discovered? What cued people into the this new industry?
So everyone points to Mali, Africa. So in 1987, a water well was being drilled in near a local village, and some worker lit up a cigarette and it exploded. Turns out that essentially pure hydrogen gas was coming out of this shallow well. And that was when it really just lit up on people's radar screens. Fast forward to about 2012, that well was put on production for natural hydrogen. And at first, was used for internal combustion engine to generate free power for the local community. And then as of a couple of years ago, then that's now being used for a fuel cell.
Oh, okay. Wow. Okay.
Yeah, which is extremely cool. But that is the only thing we know about producing and using natural hydrogen.
That yeah, that's amazing. And I guess now, like coming from, I guess 2012 was that when you said it was found, to now, are we finding that you can use similar um, skills and technologies that we had used in oil and gas for decades? Is it similar skill sets that you can use to find geologic hydrogen or natural hydrogen?
It is. It's not similar environments. So we're not looking sedimentary basins with an organic rich source rock that requires millions of years of thermal stress in order to create petroleum.
Hmm.
But it is not a coincidence that the principals in some of the main firms, let's say Hytera and Coloma and others, many others, come from the oil and gas industries because there's just a lot of natural overlap between how you look for, let's say, petroleum and natural hydrogen. Different environments, but as I like to call it, the same rock fluid network
Mm.
principles. Yeah.
And so what does that look like from a geography perspective? I'm curious, like, does it reshape the global energy map if hydrogen it ends up being like a big source of well, I'm guessing it would be continuously renewing resource,
In,
like.
indeed. Indeed. I mean, it could reshape the global energy map. Every week, I feel like on LinkedIn, there's a new location that's announced where natural hydrogen has been detected either by soil sampling or is being investigated with other technologies. So last week alone, South Korea, West Virginia here in the United States.
Wow.
But literally, I keep lists of where hydrogen is being explored for, and it is worldwide, Jason. And
Wow.
and that is a product of, I think, of natural hydrogen being produced by dozens of geologic uh, mechanisms.
Hmm. Wow. And just thinking about other extractive, right, oil and gas. I mean, we're in
Yeah.
Houston, Texas. So many family members, relatives are in the oil and gas space, heavy industry, drilling, right? Like, and a lot of geoscientists. Like, so it sounds like the labor, similar skill sets could be used for geologic hydrogen and
Yes.
extracting. Would you, what is in terms of as a geoscientist, what would you be looking for to know if there is a reservoir, if that's the right word for it, like underneath you, and
Yeah.
like, and then from a drilling perspective, how would one even drill, like for it? I guess.
I mean, to start off with, we will be looking for porous and permeous reservoirs,
Okay.
similar to oil and gas. The reservoir rocks in Mali are principally carbonates and a little bit of some sandstones. The porosity, I think, is about 12%. In terms of producing it, we just don't know yet, Jason. We know that the engineering is going to have to be looked at very precisely because hydrogen is corrosive to steel.
Yeah.
And so some of those technologies will need to be adapted. But for now, what we know from Mali is that the reservoir rocks seem to be porous rocks. And the seal rocks, in that case, are dolerites that are continuous across the area, tend to be low permeability units.
Okay. So you would maybe drill through the that rock to get to
Yep.
the reservoir, and then would it almost be like venting? Like, would you have to worry about other fluids that accompany it, like other gases, like in oil and gas, or is it like has there been any? What is that like? I guess.
I think so. Worrying about other gases, I think that's not a concern. What I would actually be hopeful about other gases is that hydrogen and helium are often found together.
Oh, cool. Okay.
And there's a huge market for helium right now. And in fact, Gold Hydrogen announced yesterday that from their Ramsay wells down in the York Peninsula in Australia, southern Australia, that their helium is actually helium 3, not the more abundant helium 4. And
Hmm.
helium 3 is so rare, in fact, that there have been talks of mining it from the moon. And helium, exactly,
Oh,
helium 3 sells for orders of magnitude more money than helium 4 does. So
okay.
the coincidence of natural helium or of helium with natural hydrogen is a game changer, because that's the way that you're going to generate cash in order to then prosecute a technical work program for exploring for hydrogen.
Wow. Okay.
Yeah.
Um, that's fantastic. So when you look at the landscape with companies in the space, is there any company or any set of companies? I think you mentioned a couple that are sort of market leaders that our listeners should be like focusing in on or paying attention to.
Yep.
And what's the state of maybe even startups in the space? Like, you
So what I do, I try to follow everybody, but there are probably 60 to 70 startups in natural hydrogen right now. What
know.
I try to do to learn is to follow closely those companies that are publicly traded. So, for example, Quebec Innovative Materials, sorry, it's QIMC, I can't remember exactly what it stands for. In Quebec, they're publicly traded. They release information. In fact, last week they had a webinar about their recent soil samples and their geophysical surveys. Gold Hydrogen, again, they announce information about their wells. And then Hytera, they just put out an investor presentation yesterday. And so those companies that are publicly traded, they have to put out information about their exploration programs. And so it helps people like me who are following the space very closely to learn a little bit about ideas of what exploration activities, ideas are being pursued.
No, okay, that
Other companies understandably are quite quiet.
makes sense. Like maybe they're in stealth mode, I guess is the
Yes.
common term. Uh, well,
Yes.
I'll pause for just a minute and just we do allow questions. So from any of our attendees, please do if you have questions for Allegra, please do ask them, and we'll be happy to answer them or talk about them in our call.
Great.
I think looking at it globally, is there a market leader like from a like is there a country that's sort of leading the pack, so to speak, in terms of support or government support or or even talent? Like,
Yeah. I mean, the thing I love about natural hydrogen is that there are companies active in it worldwide. So Australia, definitely first movers, but Hytera is an Australian company, but they're exploring in the mid-continental rift here in this country. A lot of startups here in this country, mostly exploring in the mid-continental rift, but we're aware of exploration taking place in other places. New Mexico, Rio Grande Rift, that's another place people are looking. Spoke with Nativo Energy a couple of weeks ago. They're looking in Uruguay. We know that there are natural hydrogen, let's see, examples probably in Argentina, Brazil, and Colombia. And then, of course, the drilling and sampling and surveying that has been done in Europe. So, in the foothills of the Pyrenees. So, France and Spain. So it's just worldwide, Jason. And so that's another reason why it's just so exciting to be in natural hydrogen right now.
that's awesome. So
It's
we
awesome.
we do have a couple of questions. So one is from Rick. What is the mechanism for H2 generation and migration?
About hydrogen migration. Yeah. So I posted about this on LinkedIn a couple of weeks ago that migration of fluids, specifically natural hydrogen, keeps me up at night. I literally lie in bed and think about migration. It probably is. So hydrogen has an interesting solubility in water relationship. There's a lot that depends on PBT, but it probably is dissolved in water in the sub until about possibly 800 meters, and then it probably comes out of solution and exists as a free gas. We know that it probably also advects like on clay particles, and then there's probably follows Darcy's law, perhaps Fick's law. There's a lot of physics that we still really need to understand about the migration of natural hydrogen.
Hmm.
What we know on a larger scale, so if we get beyond the molecular scale, is that natural hydrogen is probably taking advantage of faults and fractures in the subsurface to migrate along. In fact, my research group at Stanford did some soil sampling in the vicinity of the San Andreas Fault because we wanted to see if that was a pathway for natural hydrogen migration. And for sure, we think that's a viable mechanism for one, because that's actually been looked at for decades. For two, because the serpentinization process that actually generates hydrogen in the subsurface is a volume increasing reaction. And so it naturally fractures the rocks in the subsurface because of that volume expansion. And so we know that hydrogen is taking advantage of faults and fractures in the subsurface.
Mm. That's really interesting. Yeah. Next question. Over the past 3 to 4 months, has your confidence in the economic viability of geologic hydrogen gone up or down, and why? Um,
Way to get right to the point there. Let's talk money.
yeah. Yeah.
Okay, economic viability. I am bullish on geologic hydrogen because of I think it exists worldwide. So I think we will find signs of it worldwide. What what gives me pause, and I think all of the other explorers pause, is that the only accumulation of natural hydrogen that we have as an example is the case in Mali.
Yeah.
And that is not a commercial accumulation that's being fed to a grid or being, taken off for transportation as ammonia, et cetera, et cetera. So it is not the case study that we all need to make hydrogen a clean energy source for our world.
Yeah.
That said, there are a lot of really smart people working on this problem. I have no doubt that the future is very bright for natural hydrogen in the 5 to 10 year time frame.
Gotcha. Oh, that's great. Next question. So I told you, Allegra, there's going to be lots of questions. So is there any need to further stimulate these formations in some manner to increase reaction and production?
Yeah, stimulated hydrogen is a huge part of the conversation. And there's, one reason why is because ARPA-E, the arm of the DOE, put millions of dollars into funding research on stimulated hydrogen. And in fact, the director of that program, Doug Wicks, is here at this conference that I'm at in Alaska right now. I think that stimulated hydrogen is a viable way to make this an economic resource. So, seeking out iron-rich formations, banded iron formations, etc., and then generating hydrogen in situ as a renewable process, I think is super promising.
Hmm. Oh,
Yep.
very, very, very neat. I guess, um, I guess a question I might have, because I have family members
Yeah.
that are in the land business, right? And they do research on mineral rights.
Yeah.
Just existing sort of framework of mineral rights and state by state. Are there any gaps associated with like this new sort of a source of energy that particularly if
Yeah.
it migrates like that, we have to consider? Or?
I think the regulatory piece is it differs all over the world. So
Yeah.
France adopted legislation about this in 2022. And I think that partly that's because some of the main researchers say Isabelle Moretti, she's in France, they've been able to push for that. In California, it's unclear how hydrogen and helium wells might be permitted. There are many states in this country that the permitting is very friendly. So Kansas and Iowa and Nebraska, it's very straightforward how to do that. I think Canada is probably pretty straightforward as well.
Okay, no, that's great.
Yeah.
Um, so another good question: what hidden geological microbial dynamics might we discover by pursuing natural hydrogen, and could these insights lead to new breakthroughs in sustainable energy?
Wow. Yeah. So another person who's here is a microbiologist, Alexis Templeton from UC Boulder. And she and I were talking yesterday, and it's not it, it's likely that producing geologic hydrogen from the subsurface will alter microbial communities. Microbes depend on hydrogen for generating energy that they then generate methane from those reactions. And so that's just something that we need to study and understand in a lot more detail.
Hmm.
Could it lead to breakthroughs? Sure. I mean, there are ideas that we can somehow have these microbial communities, stimulate them to then generate hydrogen. Those ideas are in a very early stage.
Very, very cool. Um, well, all please do keep the questions coming. Allegra is knocking them out the park. I do have a couple of questions, like thinking about, careers and people that are wanting to get into
Yeah.
the careers. Like, what would you recommend for
Yeah.
someone? Yeah, what's the best
Yeah.
way to get started in geologic hydrogen? Would you say?
So for oil and gas professionals, I think a really helpful framework for this is to consider it as just another rock fluid network, similar to CCUS. We inject carbon dioxide in the subsurface, and then we think about how it moves both as a molecule and on a larger scale. For oil and gas professionals, then they may need to then branch out and go back and retool about hard rock environments. So learn about mafic and ultramafic rocks, learn about the serpentinization reaction, learn about radiolysis and how that works. So I think the retooling it's not a heavy lift.
Mm-hmm.
For people just coming out of school, I think natural hydrogen is, it's a natural fit for them to think about in terms of just another clean energy source. And soon, I don't know if you said at the beginning, but I'm leaving my Stanford job. Tomorrow is my last day. I'll be a consultant full time on Friday, and I'll soon be offering my classes in natural hydrogen. And so I hope that is a resource that folks can use who want to get into natural hydrogen exploration.
That's
Yeah.
fantastic. We will, if you're okay with it, provide your contact
Yeah.
information to all the attendees at the end of the webinar, so people can reach out to you directly, either for consulting or just for mentorship or questions that they might have.
Great.
I do remember you mentioned that there was a Bible out there, and I think you had sent it to
Oh,
me. What was that again? And
yeah.
you mind? Yeah.
Yeah. So the canonical paper, I did refer to it as the Bible,
Yeah.
is by Vyacheslav or Slava Zagonik. It was published in 2020, and it goes through pretty much all of the habitats of geologic hydrogen, all of the sources, lots of maps about where it's been detected. And so that is a wonderful place for folks to start. There's also a wonderful article in Science that was published in 2023 by Eric Hand, which is a really nice introduction to natural hydrogen. So those are the two papers that I would recommend for folks that want to get involved.
Okay. Perfect.
Yeah.
Yeah. So, what have you found is missing in the research literature right now from Aaron?
Yeah. I think probably migration.
Migration.
Migration and migration physics. The other topic that I'm super passionate about as a rock fluid scientist is seal capacity, capillary entry pressure, seal processes, column heights of hydrogen. That's another thing that just isn't out there yet. And it's just because we don't know enough. We don't have enough information in order to really explore those topics.
Mm-hmm. Mm-hmm.
Yeah.
So, for another question from Sean, do you think multispectral or hyperspectral imagery data at 5 to 10 millimeter resolution would give direct approximation of surface concentrations of hydrogen?
Yeah, it's definitely in the conversation. There's someone on LinkedIn that posts about that on a regular basis. at this natural hydrogen conference in Alaska that I'm at, that topic came up and is of interest because so much of Alaska is remote. And
Hmm.
so having that kind of remote sensing in order to get at least in the ballpark of where nitro hydrogen might be is going to be critical in remote regions such as Alaska.
Hmm. It, just thinking about how it could transform sort of the energy mix. Um, is proximity to the grid
Yeah,
and the drilling costs? I guess
yeah,
those are the factors to consider when you're looking at maybe.
yeah.
Yeah.
Offtake is a huge question mark. Of course, it's excellent if it's located next to a coal fired power plant that you want to shut
Yeah.
down and transfer it over to hydrogen.
That'd be perfect.
Um, the ideas for transporting hydrogen are everything through pipelines, which if you blend it in with natural gas into a natural gas pipeline, then you're not getting the bang for the buck that you would from using hydrogen natively. So you would need new hydrogen pipelines. You could liquefy it and transport it in trucks. You could also combine it with nitrogen and transport it across oceans as ammonia.
Yeah. Oh, so that kind of tracks along the lines of
Yeah,
the existing industrial complex
that's
interests.
exactly right.
Yeah. Um, and also the challenges, right? I guess with being such a small molecule, it's caustic to pipes, like all of that transportation is still.
That's right. And it's leaky. It's
Yeah.
at least it's tiny.
Yeah.
Yeah.
Um, okay. Is natural hydrogen mostly focused on serpentinization reactions? Or I can't even say it properly.
Yeah. Yeah. I would hazard to say that nearly all, I know not all, but almost all explorers for natural hydrogen are focusing on ultramafic and mafic rocks where serpentinization can happen and then produce hydrogen.
Gotcha.
Yeah. Yeah.
And for like a wildcatter, that would be like certain geologies are primed to more likely have that. Would that be a fair sort of way to think of it? Or
Yeah, that's right. So you would look at surface geologic maps. So, for example, all along the west coast here of like California, Oregon, Washington, Canada, and then up into Alaska, where I am right now, you just look at these subduction margins where you have ophiolites that have been scraped onto land and are, probably also in the subsurface. And then that is one environment of many types where you would look for natural hydrogen.
Mhm. Do you like with more questions? What is the replenish time for natural hydrogen compared to oil and gas?
Yeah, yeah. So we think it's vastly different. Of course, for oil and gas, we know that it's millions of years, and then you could also have preservation for millions of years before you even, millions of years for you to find the trap. That didn't come out quite right. But for natural hydrogen, it's different. We think it could be replenishing in near real time. And one of the pieces of evidence that's used to substantiate that is that in Mali, it appears that the pressure hasn't been declining over
Wow.
the last 12 years of that well being on production. So the idea is that it's being continually generated and replenished in the subsurface.
Mhm.
Of course, that's the holy grail, right? That's what we would like. And I think
Yeah,
that's one of the reasons why stimulated hydrogen is so promising.
yeah, it's fantastic. I mean, I guess with maybe some of the oil and gas clients, are you seeing companies? Are you seeing any of them taking a look at it and thinking of their
Yeah.
sort of energy mix as a portfolio now of including maybe hydrogen or
I'd say yes and no. I was at a conference in 2023, and all the majors are still on the sidelines. I talked to all of them as a Stanford scientist. So Shell, BP, and ExxonMobil, and Saudi Aramco, and on and on and on and on and on. I talked to all of them, and they're all watching. And I think that's fair. I think when they're ready to go, they will be able to put into place incredibly detailed programs because they have the capital, both human and monetary, to do so.
Mhm. um, I know we're almost at time or right at about time. I guess the last sort of question for me from just a career standpoint, um, if you're just coming into, you're just about to leave the workforce and
Yep.
you want to get into energy and you're thinking about
Yep.
geologic hydrogen, natural hydrogen, what would you recommend someone do? Like like would they study geology? What are your parting
Yeah.
sort of thoughts and recommendations?
Yeah, I think the geology background is key, obviously. But I will say that the person I work the most with on a daily basis is Aaron Matson. And he's an MBA type. So he's a business type who has educated himself extensively in natural hydrogen. He knows that he still needs geology experts like me, but he has tooled up in this field, and so I think that it's going to take all of us to make this nascent exploration opportunity a success.
Mm-hmm. Oh, that's fantastic. So
Yeah,
there are multiple ways to get into the space, and
agreed. Yes,
fantastic.
absolutely.
Well,
Yeah,
Allegra, I am. Thank you so much for being our guest on this month's webinar.
my
30 minutes
pleasure.
flew by.
Yeah,
Apologies for
it
the
did.
audio issues.
Yeah,
Um, we're recording the session, so we'll make this recording available to
great.
you and also to all our guests. And is it okay if we provide your contact information to everyone? And
Please do. That would be lovely. As of Friday, I am a full time
yeah,
consultant in natural hydrogen. So I'm
so for
leaving the ivory tower.
so for all of you companies out there listening in,
Yes.
please do reach out to Allegra and hire her for a
Yep.
consulting project
Yep.
on natural hydrogen.
Yep.
Well, thank you so much. Safe
Thank you
travels.
so much, Jason, for reaching out. This has been a blast.
Okay. Well, everyone, have a great rest of your day. Our next webinar next month will be on carbon credits.
Oh,
Um,
cool.
so we look forward to seeing you there. And again, thank you, Allegra, and
Thanks a
you
lot.
race
Take care,
your
everyone.
bye, y'all.